Alright, I am doing the last part of the 9C video notes, and it's the word problem section. So we have 4 word problems to do. Um, these are max-min problems. You're trying to maximize areas and volumes. You will see this in pre-calc and calculus. You'll obviously learn new ways of doing this, but we're going to learn the basics of this. So we're trying to build a rectangular room. So we're just trying to build a rectangular room here. Again, it's not perfect drawing here. It's a fixed perimeter of 320 feet. So I know the perimeter is 320 feet. So if I add up all 4 sides, it's equal to 320. And then we're going to have the width and the length. And obviously there are 2 widths and there are 2 lengths, so that's why the perimeter is equal to 2L plus 2W. And this is the function we're trying to maximize. We're trying to maximize the area. So what I need to do is, I'm trying to maximize this, but there's 2 different letters here. So I can only have 1 letter, so I can have a parabola, and we can max min it. So when I do P equals 2L plus 2W, I need to solve for one of the letters. Now, first of all, P, I know that's 320, 2L plus 2W. And it really doesn't matter which one I pick to solve for. I'll solve for L. So I will subtract 2W over. So 320 minus 2W is equal to 2L. So I'm going to divide everything by 2. So I get 160 minus W equals L. So now, remember, we're trying to maximize length times width here. So now what I do is I put this 160 minus W, I'm going to substitute it in for the L. So my area is now, instead of L, I'm going to write 160 minus W times W. And now you can see I only have 1 letter in it. So now if I multiply this out, I get 160W minus W squared. Now it's kind of written backwards, so I will write it this way. But remember, to find the vertex, where it's maximum, it's negative B over 2A. So B is 160, so it's negative 160 over 2 times negative 1. That just works out to be 80. So my width is 80. So if my width is 80, remember, my length is 160 minus 80, which is also 80. So my length is also 80. And as you learn as you get going, the more square an object is, the highest area it will be. There's my first question. This next one is, we have a piece of plastic, and it's just a rectangle. It looks like a sheet of paper. And what they did was they folded it up, and it made into a 3-dimensional object looking like that. Now, if you can read my writing here, this distance is 8. The height is x, and that's what we're trying to figure out. But if you notice, this height is the same thing, so that would also be x. But if you notice, from here to here to here, that's the 10 inches. So I don't know what that is. So it's really x plus question mark plus x equals 10. So now if I take away or combine my x's, I have question mark equals 10 minus 2x. So we're trying to maximize the volume. Remember, volume is basically length times width times height. So I have 3 dimensions that I have to maximize here. Well, we have 8, we have x, and we have 10 minus 2x. Those are my 3 dimensions. Here's the first dimension, 8, second dimension, x, and then 10 minus 2x is at the bottom here. So I distribute the 8x, I get 80x minus 16x squared. I'm not going to rewrite this. A is negative 16, B is 80. So when I do this, I do negative B, so that's negative 80 over 2 times negative 16. which reduces down to 5/2. So, and again, we maximized x, so x is equal to 5/2. Now you could write 5/2 inches or you could write 2.5 inches. It doesn't matter. It'll take the improper or the mixed. My preference is I would probably just do the improper number, so it's 5/2, but it does not matter. All right, we have our bicycle store here, and they want to make X hundred bicycles, and I will talk about the 100 in the end. They're trying to trick us a little, but the average cost for bicycles given by this function, where C of X is in hundreds of dollars. How many bicycles should the shop build to minimize the average cost per bicycle? So we're trying to minimize something. So again, where is my vertex? It's always at negative b over 2a. My x value is always that. So in this case, a is equal to 0.1, b is equal to negative 0.9. So it's negative 0.9, which is really just a positive, over 2 times 0.1. Plug this in the calculator, and I get 4.5. Now, people will type in 4.5 all the time, and it does say, please remember that the answer is in hundreds of bicycles. So really, since this is in hundreds of bicycles, I have to times it by 100 to get my answer of 450 bicycles. So, but I will see 4.5. A lot of times you've done everything correct, but you got to put it in hundreds, so 450 is the correct answer. So 450 bicycles. And our last question here, you will see this question almost guaranteed again. Now this time they chose to use the side of a barn as one side of the rectangle when they're trying to enclose, a garden to try to make it as big as possible. So what they do is they're going to use the barn as one of the sides. In pre-calc and calc, you're going to try to build an area for cattle, a fenced-in yard for things, and they'll use a river. And so basically what they're trying to say is you don't need 4 sides. One of the sides is some kind of barrier that's already there. So if I'm trying to maximize this garden here, I'm going to put it right next to the barn. And so I don't know what this is. This is going to be X, and this is going to be Y, and then this is going to be X. So I don't need 2 Y's this time, do I? Because the barn will do one of the sides. So remember, the fencing I have to put on is 32. So I'm going to highlight this in red. From here to here to here, I need 32 yards. I am going to use 32 yards of fencing. I do not need it on the 4th side because the barn is there for me to use. So what I do know is then I have 2x's plus y must equal 32 because that's how much fencing I'm going to use. Remember, we're trying to maximize the area, which is x times y, because it's length times the width. So now again, these are 2 different letters, so I need to make it in 1 letter. Now I'm definitely going to solve for the letter y here because it has a 1y. And if you remember from Unit 5, you always want to solve the variable with 1x on it. So I subtract 2x over here. Out of habit, when I'm doing my graphing, I always put the x first there. Negative 2x plus 32, I'm going to substitute that in for the y. So area equals x times negative 2x plus 32. I distribute the x, I get negative 2x squared plus 32x. So when I'm here, I have this thing here again. Again, I'm trying to maximize or minimize, so it's, again, x is equal to negative b over 2a. So that is negative 32 over 2 times negative 2, which is equal to 8. So my x, since I'm doing my x value, x is equal to 8. So I know this is equal to 8. And so my y is equal to negative 2 times 8 plus 32. Negative 16 plus 32 is 16. So my y is equal to 16. Now, if you notice, they asked 2 questions. One is, what's the maximum area? and what should be the dimensions of the garden? Well, the area is equal to 8 times 16, which is 128 square feet. And what's strange is they do ask the maximum area first, then they ask the dimensions. And I believe they have the shorter side and the longer side. You just have to fill it in correctly. Clearly, the shorter side is going to be 8 feet. The longer side is 16 feet. And that's really the end of the word problems. So please, hopefully this will help you through the 9C homework. 9C is not very long. There's only about 20 questions, so this should go pretty quickly. But as always, please come in prepared to ask questions. I always expect questions after these things.